You are watching the Movicon HMI Editor Basics self-guided video tutorial series. In this video, we will create the auto screen, that is the interface for automatic production. Hi, I'm Matt Pelletier. For this video, I'm assuming you have already completed the previous videos in this series. In the auto screen, we'll have some control over the parameters of that move sequence we've been working with. The target number of cycles has been fixed at 3, and we'll be able to see the number of cycles complete as well as the number of cycles remaining. You'll be able to change the move profile parameters of velocity and accel decel, as well as the absolute position that each axis moves out to, and the delay between moves. At the end, there's an optional part where I'll show you how to make an image move around on the screen in response to the motion of each motor. Looks like this. And you could think of each motor as a linear actuator pushing this object in first the X, and then the Y, and then the Z direction. You saw the screen was mostly edit boxes, but since we have 3 servo axes of motion, to set speed, accel, and decel for all of them at once, we'll need to use 2 things here. One is an event, and another one will be an HMI local variable behind these edit box displays, and an event then to take that data and write it into the individual axis variables that are read by the controller. We'll do that for speed, and accel decel will also use an event to write the data into both the accel and decel variables in the controller for each axis. On the top right of the page, you'll be able to just use a simple expression to calculate the remaining number of cycles by taking the target minus the number of cycles complete. The conveyors and images of the box open and boxed closed come from the symbol library. The image that moves around on the screen can either be the provided PNG image, you can use your own image, or find another image from the symbol library. A little preview on the animation taking place here, that motion is done by a combination of options under the dynamics property for the moving image. Enable visibility just makes that appear and disappear like we've done before with the start button. The X and Y movement will happen based on the current position, the feedback position of the motor, normalized here so that it will move the same distance no matter what you put in for the position values on the HMI screen. I think that's about all you need to know at this point, so if you would please open the Minilab document and once again use it as your guide to complete this part of the training. You can pause the video now and resume to see me run through these steps myself. Welcome back. I'll show you now how to go through the steps here of the auto screen Minilab. We have jogged 0 and set up in case we need them, the control panel, navigation bars, and an image file representing the product. Let's build the screen, assign the properties, and verify operation. At the end, I will show you how to do the moving image. Okay, so let's go to number 1 here. We mostly have edit box displays with labels and then a couple symbols here from the symbol library. So I'm going to do it here like this. I think I'll delete these things from before. And I'm going to copy from one of the axis screens the velocity and accel copy and paste that in there. I didn't need this. Okay. So this will be the velocity and accel decel. I'll just relabel these here. Velocity, ac dec. Maybe a little bit further apart on this one. Okay. So I copied those because they were formatted about the same as how I would want it on this screen also. I'll copy one of them here again for the cycles. Before I forget about it, I better check those properties under Style and get rid of this engineering unit, and the format value should just be X. Now I'll make that label cycles. And let's do the cycles complete and remaining here also. This one is complete. This one is remaining. Now these two are read only. So we'll do read only and spin enable. Removed. Okay. Now for the positions, I'll copy and paste this. But of course, position is the unit of millimeter. I think the format value should have 2 decimal places, x.xx. This was pos x. Copy these 2 here to make pos y and pos z. Y, z, and paste 1 more here for delay. The delay will be engineering unit second, and format value 3 decimal places. Now it all looks about right. Let's see what the tips here are on the object properties. I'll refer to these variables here for cycles, the positions, delay. Okay, so the cycles, I'll look under variables for search filter by cycle. Okay, that's the cycle target number of cycles. And this one will be the number of cycles complete. Okay. Now for position of X, I'll search here for pos. These are the absolute move positions. So this will be X move abs pos. This one is Y move abs pos. And this one is Z move abs pos. And delay is in seconds. Let's look for that word here, delay, HMI delay. Okay. Now it says here the velocity in XL decel edit box display should use a new HMI variable called movevel and moveAcDec. Data type float with some initial value and marked retentive not shared. So let's do that here. Velocity. I'll click on this display variable, and I wanted a new variable called movevel. Okay, puts it right in there, but the data type is word, so right click brings up the properties. I will choose float, that's F for float, retentive not shared, so it remembers the value, and scroll down here to find the initial value. I think we were using an initial value of 180. That was pretty good here for this demo. Okay. And okay, now we have this local variable in here. I'll do the same thing here for AcDec, the edit box display variable, with a new variable called moveAcDec. Okay, change that one also here to a float. It's F for float, retentive not shared, and initial value 36,000. Okay. Okay. Step number 2 here is to create an event, because writing to a local variable alone is not going to send anything to the controller. We need a new event called update movevel, looking for a change in this variable. So that's here under events, more toward the top. Events, and add a new event object under general here. Let's call that one update movevel. The event variable is this same movevel variable. Okay, if it changes, then we'll do these commands. The new command is to move value from that local variable called movevel into one of the axis variables. I'll search up here move x movevel. Okay. Now rather than totally recreate it, you can copy and paste. Let's paste 2 of them and go in here and edit this x into a y, and we'll edit this one, this x into a z. Okay. So we should have x on the first one. We have y on the first one. This is a little issue with the software. It seems like when you copy and paste, sometimes it doesn't always want to do exactly what you had. I can move this one back to x, and now the second one is also x. The way to work around this is just click OK so it commits that data, and then just come back in and go through and be sure that they're all correct. There's a Y, and there's a Z. Okay. Okay, in this command list, and now we need to do something similar for the deck parameter. Another new event object named update move deck. Looking at that move deck variable, there's move deck. See if that one changes. And if it does, I'll do a new command here to, like before, move value of this move deck into the variable. I'll search for acceleration first. What move accel for the x-axis. Lots of moves going on here. Hope that's not confusing. Okay. And to avoid that issue we had before, let's click OK to commit that data and then come back in to copy and paste 3 times. Then edit the second one down to the y-axis and the third one down here to the z-axis. Let's check all those to be sure. X, Y, and Z. Okay. Let's click OK to commit that data also, and then come back in, and you can hit copy again. And when you hit copy and there's more than one command on the list, it will copy all of them. Copy and paste. And now I'm just going to, instead of changing the axes, I'm going to change the XLs here to decel. And I'll copy that word decel. Okay, and then over here to the y-axis, let's call that one decel. And the z-axis decel. Okay. Let's check those again here. Yep, X, Y, and Z. All right. So that was step 3 here to create the move value commands. Now there's a note here on delay. And the conclusion is that if you want it to be in seconds, it will still be stored as a word, even though I have a decimal point in there. If I want seconds, there's got to be 3 decimal places afterwards, since the value behind there doesn't have a decimal place really, and it's in units of milliseconds natively. Additionally, it says that the resolution is 4 milliseconds, so set the spin step to 4. I'll go here and check my spin step here as 4, or it could be anything higher than that. The remaining field is this mathematical expression here and read-only style. So let me check that here for remaining. Let's search for cycle again. Those are the 2 variables we'll need in the expression. Clear that old one out of here. Cycle target minus cycle complete. That's it. All right. And now let's make one last check here on these edit box displays. Just checking out here the min value and max value and other items here. Like for the cycle spin step, maybe I want to go by 1 instead of by 10. And what's the max value, max number of cycles? That's probably too many. Maybe 999. Velocity, on the other hand, that could go up by 10. Deck goes up by 100, just like we did on the jog screen. And what about these for position? I'll just select them all at once. That way whatever I choose will apply to all of them. Spin step in millimeters of 100 might be too much. What do we do like 30? This is all somewhat arbitrary. The other thing here is it looks like I'm not allowed to have a negative value of position, and we do want you to be able to put in a negative value for position. You could just copy this syntax here and then put the negative sign in front of it. And let's commit that data. Delay, I know we looked at already. I think that one's good. So this is the minimum here to verify operation. Let's just be sure that this works before we worry about the animation part of it. So let's run this here, save it. And the right way to operate this is first be sure you have your zeros set. I think I've done that already. We want to reset the remaining number of parts in case it had been run previously. Then adjust any data you have here on the left side. Servos on and start. And there she runs. It's doing the second cycle and running. Seems to be pretty good here. Now let me see if I can mess this up a little bit and change the number of cycles here, and maybe let's crank up the speed a little bit. Crank up the XL, decel, add a 0 to everything here. And let's even put a negative on one of those. Okay. I'll put a little delay maybe of 1 second. You don't want to get too crazy or it'll take a long time for the motors to go to the position that you're asking for. Now reset and start this one. It's moving. The X, the Y, the Z, and they move back. Okay, it's doing it the second time here. And moving back to 0. Now I've brought up this watch page just to confirm that my events are working properly. I want to be able to change the velocity, and I should see it change on all 3 axes here at the same time. Looks like that is correct. Same with XL, decel. I'm looking there at the value, and it's changing. So that means it's working. You may also be able to tell just by looking at the motor, but that's not always possible. Let's close this now. I tried to point out a lot of these troubleshooting tips as I went through it, but just be real careful for those copy-paste errors, especially in the event. Be sure that you don't have anything wrong there. Go through and check to be sure you have the right units and a reasonable decimal point resolution for each of the fields. And check that max and min value in spin step also. And like I did there, add variables to that watch window to confirm that your events are indeed working. And for certification, just be sure that basically everything works properly and prove that it does work. Now let's go on to this optional visualization of the moving widget. And really we need to start by adding something from the symbol libraries. And the 2 you'll need are container and conveyor. Let's start with a conveyor. You can really use any conveyor that suits your liking. I'll use this one here and this one there. Let's just lay them out roughly where we think it's going to go. There's flexibility in which direction and starting position you use on these. And then I want to put a box to give the appearance of a box closing on the item. So first I'll put down this closed cardboard box. Then I'll put on top of it this open box and just make sure it covers the old one here. And we'll just toggle the visibility on this one so it will disappear and then look like there's a closed box in its place. Now for the moving image, you could take anything from these libraries, a bottle or something like that. But what I will do is I'm going to take that custom image, and just like we did the Yaskawa logo, I'll just replace that with the custom image. So that logo was on the header bar. No sense in reinventing that process. Let's just copy this header bar and put the Yaskawa logo here. Now I'll go back to the properties and let's find the background attributes. And I'll just change this static image to this fidget widget. Okay, open that. See how that looks here. And then I can just make it the size I like. And I'll have it start right there. That was part A here. Now let's make this thing move. First in X and Y directions. For it to appear only when the HMI detects a part present, there's just a variable here in the HMI that simulates when a part should be present. And that's under Dynamics. Enable visibility, and the variable is called part present. Okay, so when part present equals 1, there's a part present, and that will enable this visibility. Now for the fun part, let's make this move. Also under Dynamics, there's move horizontal and move vertical. And an example of how you could do this is take the current position divided by the absolute target position times some value. In this case, 160 will move 160 units or pixels by the end of the move. And it will move from the starting point where you've placed the image on the screen. So this first term here should go from 0 to 1 as the current position counts up and eventually equals the move abs pause. and multiply by 160. So let's look at that here. Enable the X movement. And the variable is that expression. So let's be sure we have the variables we need. The position variables, expression, current position, divided by that target final move absolute position, times somewhat arbitrary value of 160 pixels on the screen. Okay. Now it does tell you that there's an error, but you can accept this and use the expression anyway. It will work. And let's do something similar here for the Y direction. Enable Y movement, and the variable expression will be the Y curve pause divided by the Y move abs pause. And let's multiply that also by 160. Okay. And let's use that expression. You could test this much by itself, but let's just go ahead and do the Z-axis with this little expression that will make it look like this is moving downward by becoming smaller, up to 50% smaller. That's called scaling, dynamic scaling, still under the dynamics category. The scaling variable is yet again another expression. We said it would be 100 minus the Z current position divided by the Z move absolute position multiplied by 100. This whole expression will then change from 0 to 100 as the motor moves to whatever that final position happens to be. Okay, and use that anyway. And the scaling will go from 0 to 50%. And that's what it shows here. And let's see how lucky we get with the placement of all these pieces and try this out here. Let's reset this and start it off. Sometimes the first one's a little bit rough. And I forgot to make my box disappear here too. But it's generally taking the right path. Maybe we just need to increase that 160 by a little bit here. So I'm going to try again here real quick. I see now the part I missed was the end value for X and end value for Y. I left it at 100. So that's why it's not going to the full amount. That's up here on enable movement, 160 and 160. And I want this box also to disappear along with the moving object. So I'll enable visibility according to the variable part present. Okay. And let's run this now. Okay, I'll reset and start again. There's a box. Yeah, that looks better. Goes down. It went down to 0%, it looked like there. Let's check that out. Okay, but that's the right idea. I think I'll close this out here. And looks like I've got that 50 should have been under min percent scale. I had 50 for end value for scaling. It should have been here. Min percent scale 50. And it's probably not critical, but let's leave this end value back to 100 where it was before. And try it one more time. Reset and start it off. She's moving down to the X, down to Y, down to Z, 50%. Looks good. Okay. Now sometimes as you're working with this, depending where the motors were, the animation may look messed up the first cycle, but it should recover and be fine afterwards. And with this we conclude the Auto Screen Mini Lab. Thank you for watching this video, and please go to www.yaskawa.com/HMI for more information on Yaskawa's HMI products and Movicon HMI editor.